9.4 Transition Matrices. A transition matrix is a square matrix that shows change from one state, a conditional location at a point in time, to another where the change follows the same rules each time. So looking at the dot points down below, you'll see 75% of the shoppers who shop at Eastworld one week will shop at Eastworld the next. So we're talking about two shopping centres, Highton and Eastworld. So I've labelled them E and H, and jumping back up to the diagram, you can find E here. So what this means, the 75% of shoppers who shop at Eastworld will then shop at Eastworld the next week, and again, and again, and again, because, you know, they have no imagination and they don't go outside their comfort zone. Whereas 25% of the shoppers who shop at Eastworld one week will shop at Highton the next week. So the rest of those will then go across to this guy here at Highton. Similarly, we'll change colour, find a nice light blue, make it different enough. 90% of the shoppers who shop at Highton one week will shop at Highton the next week. So we've got Highton here, they shop just at Highton again. So these are the boring people that don't move out of their comfort zone. And 10% of shoppers who shop at Highton one week will shop at Eastworld the next. So as you can see, there's a percentage of people that travel from one place to the next, and a percentage of people that just stay where they are and they don't want to change. If you looked at these two, let me just go back to this. If you looked at these two numbers, so we'll go to we'll go to Eastworld. We've got 25% go across to Highton. 75% of those stick with Eastworld. If you have a look at that, add them together, we've got 100%. So we're talking about all that population or all those shoppers. How I then put that into a transition matrix is I list it as where they've started. So I've listed it at where they've started here, and it's this week. I've got E and H representing Eastworld and Highton, and then where they're going to go to next week. Now, I don't write this in here as a percentage. I do write it as a percentage, but I put it in decimal form. So as you can see, let me just change. Hey, I think this diagram's wrong. Oh no, Eastland. Yep, no, I'm good. I'm looking going, hang on a minute, I think my letters and numbers are in the wrong spot, but they're not. I'm just reading it upside down. So we had 75% of people start at Eastworld here and then end at Eastworld. So this 75% gets taken from here on the left-hand side and put in here as 0.75%. Let me just use a highlighter. It's a little bit jumpy, I'm sorry guys. My screen's too touchy today. As 0.75. So remembering with your conversion, it's to get from percentage, 75%, you divide it by 100 and it'll give you 0.75, which is 75% in decimal form. Similarly, the 25% on the left-hand side will end up being the 25% here. Now, remembering our 100%, if we add downwards 0.75 plus 0.25, it equals 1. So each column must equal 1. So we've got 100% of people at one location going to either the same or another location. So this is how a transition matrix works. Now it's always going to be a square matrix because every location has to go to another location and itself. All right, so starting on examples. Example 11. So if you're working through your textbook, I'm on page 87. For this diagram, find X, Y, and Z and find the matching matrix. So we've got a couple of things to do here. First of all, we've got to add up all of our percentages. Now remembering that each letter, so the letter A, has to equal 100%. We'll just see where we're at the moment. So leaving A. Leaving A so far, I've got 65%. I've got an X, and I've got a 5%. So I've got 65% plus 5 plus x should equal 100. So far I've got 70 plus x equals 100. Therefore, x is going to equal 30. So this guy over here is going to be 30%. Moving on to B. Remembering again, B has to equal 100%. Change colours. Let's choose green. So leaving B, I've got a 45. I've got 35. And I've got a y. So 45 plus 35 plus y equals 100. 45 and 35 is 80 plus y equals 100. Therefore, y equals 20. Lastly, I have C. So I'm going to make that yellow so everything's different. No, let's go blue. I like making things colourful. That's why the slides are pretty, bland and white. Apologies to Fiona who likes colour. Okay, so we have 50 heading that way, 40 heading that way, and then we have Z. Remembering that it has to equal to 100%, so C is equal to 100%. And from C we've got a 50 and a 40 and a Z equaling 100. So 90 plus Z equals 100. Therefore, Z is equal to 10. Now putting this into a matrix. We're going A, B, C. We're starting up the top here at A, B, C, and A, B, C. You know what, I'm going to scratch that. I'm going to put these in a different colour so you can see the difference. Otherwise I've got way too much writing going on. A, B, C, and that's where they've gone from. A, B, C. Now, A to A was 65%. So as a decimal, it's 0.65. A to B we found was 30%, 0.30. You don't have to put the second zero if you don't want to. I just like to keep it nice and neat. And A to C gives us 5%, which is 0.05. Now B to A, B back to A is 0.35. B to B was 45%, which is 0.45. And B to C we found was 20%, which is 0.20. C to A, 40%, 0.40. C to B, 50%, 0.50. And C to C was Z, which is 0.10. Now back to blue again. I'm just going to double check these. 0.65 plus 0.30, which makes it 0.95, plus 0.05 gives me 1. Adding downwards, 0.35, 4, 5 and 2 gives me 1, and 4, 5 and 1 gives me 1. All right, so as you can see, each column totals 1 or 100%. Now part B asks us to go from the current state to the next state with A, B and C. And it says find X, Y and Z and draw up a transition diagram. Now looking at column A, just these guys here on the left, I've got to remember that remembering everything has to equal 1. And I know that, so that's column A. If I go 0.2 plus 0.4 equals 0.6. 1 take away 0.6 gives me 0.4. That means that my X value is going to equal 0.4. So that's this guy in here. It's going to be 0.4. Similarly with B, remembering that the column equals 1, so far I've got 0.1 and 0.6, which equals 0.7. I take that away from 1 and I end up with 0.3 or 30%. So my Y value here is 0.3. And lastly with C, I've got 0 and 0 so far, which equals 0. 1 take away 0 equals 1. So Z is going to equal 1. The second step, or the second part of this question, says draw up the transition diagram. So I start with my 3 points, A, B, and C. Now to get from A to A, I do my loop, make sure you put your arrow, and I label that according to my matrix, 0.2. So that would become 0.2, or 20%. When you are drawing up the transition diagram, it should be in percentages, whereas the matrix should be in decimal. Now to get from A to B, I'm going to go around here so I don't write through the B. It is 40%. Remember my little arrow down that way. And then A to C is also 40%. We'll change colours for the next one. We're going to go B. So to get from B to A, it was 30%. To get from B to B, put my arrow on it, it was 10%. To get from B to C, we had 60%. Sorry, it's wobbly. I'm too heavy-handed again. And we'll go one more colour. Light purple. It's different enough. I'm trying to keep colours different enough such that you can see how it's all happening. Now, C doesn't go to A, C doesn't go to B. Now, because they're both 0% lines, I don't actually need to draw them. So the only thing I need to put on here is C to C, which is Z, and that's 100%. So once you get to point C, you stay in that. Moving on to example number 11. Actually applying or finding out sort of numbers based on this transition matrix. So example 12 says a certain species of bird nests in 3 different locations, A, B, and C, on a peninsula. So it could be, one could be in a particular park, or 3 different parks. One could be up one tree, and then the other locations could be 2 other separate trees, still in the same park. It doesn't specify, it just says 3 different locations. The birds change their nesting location each year according to the transition matrix T, where, and then we've got our matrix below. This year there are 400 birds in location A, 600 nested in location B, and 210 birds nested in location C. That's like nearly 1,300 birds. So looking at our matrix T on the left, we can see that our column A equals 1, our column B equals 1, and our column C equals 1. So that means I've got all my numbers there and I can start answering questions. Part A asks how many birds nesting in location B this year would be nesting in location C next year. So highlight her out. Starting in B, ending in C, we have 0.25. Go back to blue because blue's nice to write with lots of times. So 25% of birds go from B through to C. And we're starting with 660 birds in location B. So we need to find 25% of B to end up at C. So we do 25% times 660. Now remembering that we're using, it's easier to use a decimal format. So we're looking at 0.25 by 660. So we're talking, it's a quarter of that equals 165 birds. So 165 birds would start off in location B this year, and then next year they'll be located in location C. Question B, or part B. How many birds nesting in location C this year will be nesting in location C next year? Now, location C started off with 210 birds this year. And looking at our diagram, we've got to start off at C and we're going to end up at C. So going down here, we've got C to C at 0.7 or 70%. So 70% of birds go from C and stay at C. So we're finding 0.7 times 210 gives me 147 birds. Of the 210 that are currently located in location C, 147 of them will end up going or staying in location C, and the other 30% will head off to location A. Part C says how many birds will be in location A next year. Now this will take a few steps. I'm going to change colour. I'm actually going to erase one of those so we can see, pull out a pretty pink. Pink's my favourite colour. Okay, how many birds will be in location A next year? So we need to find everything that ends up in location A. So we need to find 40% of current location B, A, 20% of current location B, 30% of current location C, and add them all together because they're going to end up in A. So we'll start off with A through to A. 40%, so 0.4, and there are 400 birds. So 0.4 times 400 should be 160. Now we're going to go location B through to location A, and we have 20% or 0.2. So that is 0.2 times 660. And you end up with 132 birds there. And then birds that start at location C and travel through to location A, we've got 30% or 0.3. So 0.3 times 210, and that gives me 63 birds. Now if I was to add all that together, 160, 132 and 63, I would end up with 355 birds are going to be in location A next year. So just running through that again, trying to find what ends up in location A, we have a look at the row A, and we find 40% of A, 20% of B, and 30% of C will migrate to location A next year. Part D, how many birds will be in the same location next year as they were this year? So that means birds in location A will stay in A, birds in location B will stay in B, birds in location C will stay in C. Following the same format we did in the previous part, or part C, A going to A is going to be 40%. So 0.4 by 400 gives me 160. The birds staying B, or from B, staying in B, is 55%. Must be pretty cozy there. 55%, so we've got 55% of 660. So 0.55 by 660, and I end up with 363 birds. Now the birds staying in location C this year and next was 70% of the birds. We did this in part B, or part A, can't remember. And it was 0.7 times 210, and that will give us 147 birds. And adding those together, we end up with 160, 363 and 147. End up with 670 birds. Will stay in the same location next year as they were this year. So 670 birds will stay in the same location next year as this year. Now there's also work example 13 in the textbook. Feel free to shoot an email should you want a video created or a little bit more support on that. Thanks.